Let's do some exercises from Tracing Arrays worksheet number 1. Here we have an array. It's a special kind of variable that when you declare it, you need to put a set of parentheses after the name. And you can declare it by putting a bunch of numbers in a set of curly braces. And those numbers have what are called subscript positions. The first number is considered to be in subscript position number 0, and the second number is position 1, and the third number is position 2, etc. It's good on your worksheet to label these positions with their corresponding subscripts. We also sometimes call these index position numbers. So either the word index or the word subscript is how we refer to these numbers that I just write in pencil above the actual numbers that are in the array. And this is called an array. Very, very important in computer programming, computer science, and everything we do for the rest of the school year. Okay, here's another array named mScores, and I will label those numbers that are in the array with subscript positions. We always start at 0. That's just the way it works. And I want to make a point that's quite tricky if you don't pay attention to this. What's considered to be the length of the array mnums is, well, let's count. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers in that array. So the length is considered to be 8. For this array named mScores, its length is 1, 2, 3, 4. Its length is 4. Don't be confused. When an array has a length of 4, the last number in that array is considered to be in subscript position, well, whatever the length is, minus 1. So it's always length minus 1 that tells you what position number the last value is. Don't be off by 1 and think that this is position 8, because we started counting at 0, and that means that you finish your position numbers, your subscripts, at 1 less than the length. Okay, now that we've taken care of that, let's fix up my scratch paper here and proceed with the rest of the worksheet. In exercise number 1, we have a label named label1, and you're supposed to tell me what number prints out in this label. Well, let's trace the code. This is an assignment statement. It works from right to left. So whatever number this is equal to, that number plugs into the label and therefore shows up here. Well, don't answer 3. It's not simply the number that's in the parentheses. The way arrays work is that you find the index position of whatever number is in the parentheses, and you go up to that array, mnums. Okay, we're not using mScores right now. Don't be distracted by that. mnums, and you go to subscript position 3, and whatever value is there, that is what all of this simplifies to. So this is pretty much the same thing as saying label1.text equals 14. So it's very clear excuse me, that a 14 shows up in the label on the screen, not the number 3. And don't be misled and think that the number 30 shows up, because while the number 30 is the third value that you see, it's the third number that you see, 1, 2, 3, don't make the common mistake that because there's a 3 there, excuse me, in the parentheses, that you should be taking the 30. No, that's totally wrong. The people that make that mistake, they're not carefully labeling the subscript numbers above the positions in the array. And if you start with 0 and label correctly, you'll see that position 3 is really the fourth number. 1, 2, 3, 4. It's really the fourth number. Excuse me. Moving on to number 2. In number 2 here, we are adding up, not 2 plus 4 to get 6. No, the answer is not 6. It's not that simple. Let's go up here to mnums and find what number is in position 2. Mnums, position 2, there happens to be a 30. So this is really the same thing as a 30. And this mnums 4 is really the same thing as 15. And now when we add 30 plus 15, that simplifies, of course, to 45. And that 45 is therefore being assigned into label 2. So that's why the answer to number 2 is 45. Okay, number 3 is strange. There is no parentheses 2 or parentheses 3. Instead, we're using the length method. The length method. This notation is allowed to type the name of an array, dot length, empty parentheses. And what that does is Visual Basic finds the length of that array, which we earlier agreed is 8. Because if you count the numbers here, 1, 2, 3, 4, 5, 6, 7, 8, that length is 8. So what we're doing in exercise 3 here is we're taking all of this, which simplifies to 8, and it's being plugged into label 3. Excuse me. Okay, those were relatively straightforward once you know how the parentheses work and how these subscripts work. Now let's trace this next bit of code that uses a for loop. Okay, well, we have a plain old variable total. It's equal to 0. And we have j. J starts at 0 here because of this loop. And we execute this line of code. Total is currently 0, and we're adding to that m scores j. Well, this is odd. We have a j there instead of a number. But j is currently 0. So this is the same thing as saying m scores parentheses 0. What is the number that's in m scores position 0? Well, looking up here, since this is m scores, I should be careful here and label the subscript positions of this array. Always put your numbers here on your worksheet to be careful. Excuse me again. And m scores 0 is really 59. So this code is saying, what is total plus m scores 0? In other words, what is 0 plus 59? That's the number of 59, and that 59 is going into the variable total. So it's crossing out the old 0, and we have a 59 there. Then we hit the word next, which loops us back up to the top, and because for loops always step by 1 each time around the for loop in this situation, j bumps up to 1, and now we run this line of code again here, and we work the right-hand side of the equals. Total is currently 59. And what is m scores j? Well, j is currently 1. So what is m scores parentheses 1? Well, here's m scores, and here is the number that's in position 1, 75. So we ask, what is 59 plus 75? And if you can't do that in your head, just add it up. There's no shame in that. 134. And that 134 plugs into total, overwriting the 59 that was there. We hit the word next. We loop back up to the top. J steps up to 2. We go through the loop again. This time, total is currently equal to 134. And we're adding m scores parentheses 2, which is right here, 100. Excuse me, that grand total is 234, which plugs in the total, overwriting that 134. We go around the loop, j bumps up to 3. We do go through the for loop this last time when j is 3, and we carefully analyze this tricky statement here in the body of the for loop. Total is currently 234, I see. And M scores J. J is currently 3, which takes us up here. And we come in here to position 3, it's 88. Plus 88. 234 plus 88 is 322. And we go next. J bumps up to 4. We stop the loop now because J is over this upper boundary. So we circle J equals 4 as our final value, and total is equal to 322. And this line of code finally executes, and that 322 goes into label 4, making that the answer to exercise 4. Excuse me again. In this next exercise, we have sum, which is 0. J starts at 0. Oh, let's go back up and look at what happened in this previous code segment. In this code segment, when it was all said and done, we added up these numbers in our array, M scores. The 54 plus the 75 plus the 100 plus the 88 all added up to 322. This loop with this line of code is very powerful, and it can be used to add up a bunch of numbers in an array. Let's look at this next code segment that we started. Both these variables are starting at 0. We use a plus equals, which is really the same thing as up here, only instead of the variable named total, we have a variable named sum. So what's M scores J? M scores J is currently, J is a 0, so I'm coming up here to 59. That 59 is adding into sum because of the plus equals. We go around the loop again, and J bumps up to 1. Now we better analyze this to see what number this is equal to. When are we going to stop with J? Well, what is M scores length? 1, 2, 3, 4. And what is 4 minus 1? 3. So all of this right here simplifies to the number 3. It's the same as this question, only just a different way of doing it. M scores length minus 1. And we needed the minus 1 there, otherwise you will get an error message eventually. Okay, let's move on. J bumps up to 2. M scores 2 is the, oh, I was at J equals 1. I skipped ahead too fast. J is currently 1. So M scores 1 is 75, which gets added into sum, excuse me. That's 75 plus the 59 is 134. J bumps up to 2, which means we're taking the number 100 and we're adding it to 134. J bumps up to 3, which means we're up to the 88, and 88 added to that is 322. J does bump up to 4, and it stops, and the answer here in label 5 is also 322. In fact, this code segment here is the same as this code segment, only instead of having a 3, we have M scores length minus 1. And instead of having our assignment statement written out this long way, total equals total plus, in this exercise here, we used the shorter plus equals sign. Just do the same thing we were doing up there. The same answers, just a different way of doing it, and nobody gets extra credit. They're both good. Excuse me. Okay, let's take a look at the next code segment. Position is -1. J is 0. M scores length minus 1, for the same reason it was 3 up here, it ends up being 3, all of this. If M scores J equals 75, well, J is currently 0. Is the number found in M scores subscript position 0, is it a 75, true or false? M scores position 0 is not 75, so that's false. And because we have false, we don't do whatever's in the if statement, and we loop back up to the top. J bumps up to 1, and now we go through the loop again. And we ask if M scores J equals 75. Well, because J is currently 1, we look up here at M scores, and we find the number that's in position 1, which is a 75. Bingo! 75. All of this is simply the number 75 at this moment. 75 is equal to 75. That's true. So we do this line of code right here. J is currently 1, and the 1 is plugging into position. And now we loop back up to the top. J bumps up to 2. We are checking to see if M scores J, where there's a 2 there for the J right now, if that's equal to 75. We come up here, position 2, it's not a 75, it's 100. Overall 100 here is not equal to 75, so this is false. We don't look at that, and we loop back up to the top where J bumps up to 3, and then we check to see if this is a 75. It's not, so we don't do anything else. We loop back up to the top, and now J bumps up to 4, and since we're over that 3, we're finished. Label 6.text equals position. Position is currently 1, and that 1 plugs into label 6, so that's our answer. Now, do you know what we just did? We found the number 75, and we found its position number in the array M scores. We found the 75 right there. And we found this position number. And apparently that's something that's important in this computer program. We wanted, for some reason, the position number of the 75 to show up on the screen. In the world of life, there are a lot of times when software like Facebook or Angry Birds or pretty much anything needs to do what's called a linear search. In a line from left to right, we just searched that whole array and we found what we were looking for, the 75. And we found where it was. Hey, it's like a postal worker. It would be like a postal worker walking down the street looking for house number, a house where the number 75 lives. And as soon as we find that house with the 75, we ignore the house where the 10 lives and the 88. Once we find the postman walks this direction down the street, he or she keeps track of where 75 lives. And that position number, like 123 Maple Street, that position number might be what's important. And that might be the number that we would want to store in a label, the address of that house. So just trust me, this algorithm, this loop right here with an if statement in it, it's called a sequential search, which is also known as a linear search. And a linear search, again, is simply a situation where you look through an array, usually from left to right, until you find what you're looking for with your if statement. And that's what we did there. Okay, real quickly, the last one, I'm going to fast forward here. In this case, we're looking for the max. So max is equal to m scores 0. Interesting, m scores 0. M scores 0 is a 59. So I am putting a 59 into max. This is really a 59, and I'm putting it into max. So let's do that. And then position of max is equal to 0. J starts at 1 instead of 0. And m scores length minus 1 is 3 again. And now we encounter this if statement. If m scores j greater than max. Well, max is currently 59. And j is currently 1. So m scores parentheses 1. M scores 1. M scores 1 is this 75 that's kind of buried in there. 75 is m scores 1. So is 75 greater than 59? True. So we do execute these two lines of code. If it was false, we would have skipped those two lines of code. So what are they doing? Well, m scores j, because j is 1 right now. M scores j is 75, and that 75 is plugging into max, crossing out the 59. Oh, that's sad. The 59 is now crossed out. 75 is the biggest number found so far. Position of max is j. So since j is 1, it plugs into position of max. We hit next, we loop back up, j bumps up to 2, and then we check to see if whatever number is in position 2, this 100, we're checking to see if 100 is greater than max. Max is currently 75. True again. That is true. T. So let's execute these two lines of code. M scores j is currently this 100. And that 100 plugs into max. Sorry, 75 is gone. Just like it replaced the 59, we now have a new winner, 100, a new biggest number. J is currently 2, so a 2 plugs into position of max. We loop back up to the top, j bumps up to 3, and we analyze this all over again inside here. And is the number that's in position 3, 88, is 88 greater than max? Max is currently 100. False. This is a big fat F. 88 is not greater than 100. So we don't execute this code. We go back up to the top. J now hits 4, which is over the 3 that we had here, so we're finished. Except for this line of code here. Max is currently 100, and that plugs into label 7. Now, we could have just used our eyeballs. If you would have asked me, what is the biggest number in this array? I would have just taken my eyeballs and scanned from left to right. And that's what this algorithm did. I would have looked at the 59 and asked, I would have set it equal to max. Then I would have asked, is 75 greater than 59? Yes. Is 100 greater than 75? Yes. Is 88 greater than 100? No. And that would lead me to conclude that 100 is the biggest number. This is also called a sequential search. This code right here that we just traced. This is also called a sequential search, but instead of finding the number 75, we're finding the max, the biggest number. By changing, you can't see it right now, but by changing this greater than to a less than symbol, you could probably find the smallest number in this array by executing that code. Okay, finishing up. Position of max was 2, so the answer is 2 there. Do you know why we used we typed m scores 0 here instead of just the number 0? If you know why m scores 0 is better than 0, please answer. Well, maybe we'll talk about it in class. Why does j start at 1 here when in the other for loops j started at 0? Interesting. If you know the answer to that, please answer that in an essay here or a short answer. Thank you for listening.